Hi, I'm Stephen Kangisser.
And I'm Abhishek Shankar, and we're here to present ScannerVR.
Manufacturers widely use laser scanners to capture details of existing objects. Scanners analyze the built environment by collecting data on shape and appearance. The resulting data is then applied to develop digital three-dimensional models. Given the utility of laser scanning, manufacturing engineers should be knowledgeable about scanning theory and application. Some engineering personnel or technicians have the need to gain proficiency with scanners. Staff turnover necessitates the training of new scanner operators from time to time. Limited access to instructional scanning instruments presents a challenge when training operators or when instruction is offered remotely, as limited access to the equipment can impede the accomplishment of stated learning objectives. ScannerVR is an immersive laser scanner training experience that leverages the power of virtual reality to enable trainees to be present in an immersive environment where they can carry out tasks that require interaction with the physical environment. Building this experience required us to understand the scanner training process. To accomplish this task, we examined the current method of scanner instruction at university, undergraduate, and master's degree level courses. We observed instructors and trainees' interaction using a physical scanner in a traditional classroom setting. The observation revealed three stages of the laser scanning process: target placement, scanner setup, and point cloud visualization. First, the user examines the environment to be scanned and chooses where to place targets, which the scanner uses to stitch multiple scans together, creating a singular scan. The next phase is the scanner setup, where the user sets up the parameters of the laser scanner. Most importantly, users must understand the concept of resolution and quality. Finally, the scan data is collected and processed using software for stitching point data. A 2D prototype was built to permit the learning of the scanner setup and to understand the relationship between resolution, quality, and scan time. The 2D digital training tool was tested and shown to provide effective skill training.
Having established the utility of a 2D prototype, the team developed a more immersive learning experience using VR. Target placement and point cloud visualization were not a part of the 2D prototype, as the medium did not allow for interaction modalities that were not a screen touch. VR afforded the team more significant interaction modalities, enabling them to incorporate all phases in the scanning process. The 3D experience was built using Unity, a game engine that allows developers to create and deploy immersive VR applications. OpenXR provides the API framework to enable locomotion and interaction mechanics. The experience was built on a Meta Quest Pro with IoT capabilities to cast content to devices. The resulting instructional tool, ScannerVR, is a simulation system that allows instructors and trainees to understand the complexities of the laser scanning process. Trainees can interact with the environment and place targets. Targets can only be placed on flat surfaces that would not move or be reflective. A green outline appears around the target if the placement is acceptable. A red outline shows if the target placement is incorrect and the target will not stick to the surface. Interactions for the users included grabbing and moving objects, including the targets and the scanner. Multiple error and failure states were also built to ensure a consistent experience and to provide ample user feedback. A visualization for the point cloud was then created using Unity's particle system. The point cloud simulates how a scanner might work in the real world by shooting particles at objects and creating points in 3D space. The scanner settings determine the number and size of points present. The trainee is then dropped into the virtual industrial environment where they can immerse themselves in the scanning experience. Scanner VR uses IoT by allowing instructors to monitor the trainee's interactions as the trainee uses the headset to accomplish their tasks. The instructor can watch a live video feed of the trainee's performance and provide real-time feedback based on their observation. The Oculus platform supports casting video streams over Wi-Fi to internet-enabled devices such as smartphones, computers, and smart TVs. VR enabled researchers to develop an application that constituted multiple interactions within an environment in context and a user interface. This multimodal experience has the potential to impact the workplace of the future. Experiences like Smart VR leverage the internet to train the workforce of the future by providing an immersive experience while retaining the collaborative aspect of a workplace. By permitting the instructor and trainee to view the same information, Scanner VR can equitably facilitate training in locations where physical devices may be scarce due to financial or logistical constraints. Thank you.